In this support desk walkthrough, we are going to investigate a SQL Server transaction log full incident from start to finish. The aim is not just to clear an error message. The aim is to work like a support analyst, reproduce the issue, capture the evidence, understand the cause, apply a safe resolution, and then validate that the business process works again. When SQL Server says the transaction log is full, the first assumption is often that the disk has run out of space. Sometimes that is true, but it is not the whole story. The important question is, why can SQL Server not reuse part of the log? In this example, the error says the database log is full due to active_transaction. That means SQL Server still needs log records for an uncommitted transaction. Until that transaction is committed, rolled back, or otherwise cleared, normal write activity can fail. We create a lab database called SupportDesk_log full lab. The database is set to full recovery and the log file is capped at 64 megabytes, so the lab fails quickly rather than growing forever. We then create a simple invoice posting table with a wide payload column so the demo produces enough logged activity. This is deliberately a lab setup, not a production sizing recommendation. In the first SSMS window, labeled Session 51 in the slides, we begin a transaction and insert a large number of invoice rows. The key point is that we deliberately do not commit or roll back. This creates a realistic problem. An application process starts work, writes data, and then leaves the transaction open. The session may later look idle, but SQL Server still has to retain the log records because it may need them to roll the transaction back. In the second SSMS window, labeled Session 57, we simulate normal user activity. This second process tries to post more invoice rows. Eventually it fails with error 9002. The transaction log for SupportDesk_log full lab is full due to active_transaction. The failed session is the visible symptom, but it is not necessarily the root cause. This distinction matters in support work. If we only look at the session that raised the error, we can miss the older session that is holding the log hostage. Now we switch to the support analyst window, labeled Session 64. First we check log usage with sys.dm_db_log_space_usage. The expected result shows the log nearly full. Then we check sys, databases for recovery_model_desk and log_reuse_wait_desk. The important evidence is that the database is in full recovery and the reuse wait is active_transaction. This confirms that SQL Server is not just asking for more disk space. It is telling us that an active transaction is preventing log reuse. Next we run dbccopentran against the affected database. This returns the oldest active transaction and the owning SPID. In the slide example, the owning SPID is 51. We then cross-check with the transaction DMVs. This gives us the transaction start time and how long it has been open. At this point we have moved from a generic log full incident to a specific root cause. Session 51 owns the oldest active transaction in SupportDesk_log full lab. Before we take action, we inspect the session. We look at login name, host name, application name, status, open transaction count, client address, and the most recent SQL batch. This is where support discipline matters. A session can be sleeping and still hold an open transaction. Killing it blindly may cause a long rollback and may affect users. Capture the evidence first, then decide whether to ask the user or application owner to close the transaction, whether to roll back in the lab, or whether production authorization is needed for a kill command. The safe decision path is straightforward. Confirm the database and reuse wait, then resolve the active transaction. In the lab, we roll back the open transaction in Session 51 and allow SQL Server to reuse log space. In production, you normally try to get the owning process closed cleanly. Take log backups only where the database is in full recovery and the backup chain is valid. KILL is a last resort and should be authorized because rollback can take time. Shrink is not the first response. Shrink may reduce the physical file size later, but it does not fix the cause of active_transaction. After the transaction is cleared, we validate. We check the database recovery model, the log reuse wait, and the percentage of log used. We then run a normal insert to confirm the business process can write again. This is the difference between applying a command and resolving an incident. A good support note should include before and after evidence, the error, the log usage, the reuse wait, the root cause session, and proof that the workload now succeeds. The prevention work is what stops the same ticket coming back next week. For full recovery databases, make sure log backups run frequently and that failures alert someone. Monitor log usage before it becomes critical. Review long open transactions from application hosts. Size the log file intentionally rather than relying on tiny autogrowth events. If the same application path keeps leaving transactions open, feed that evidence back to development or the product team. The repeatable checklist is: capture the exact error, confirm the affected database, check recovery model, check log usage, check log reuse weight, identify the oldest active transaction, inspect the owning session, choose the safest resolution, validate normal writes, and document prevention. The value is in the sequence. You avoid guesswork, you avoid unsafe shortcuts, and you leave a clear incident history. A transaction log full incident is an evidence problem, not a guesswork problem. In this walkthrough, the visible failure was a user posting process, but the root cause was an older open transaction. The safe fix was to protect the backup chain, clear the active transaction, validate the database, and then recommend controls to prevent recurrence. This is the support desk approach: practical troubleshooting, clear evidence, safe resolution, and reusable support material.